And review a little bit about non-collinear and collinear. A big part of this definition is the lie on same. And I'm kind of pointing this out as a way to lead into kind of when we talk about coplanar and non-coplanar. And like anything, it deals with points. Points are locations in space, right? We talked about GPS and whatnot. Points lie on the same. Now, if you see here that word line is right in there, points on the same line. And that could be a combination of 2 points or many points. And we're going to say these to be collinear. Okay? You have what we call non-collinear, which would be points not on the same line, meaning these 3 points here do not allow me to draw just one line through any of those 3 points. I have to create more lines. So this is where we say this is non-collinear. And there's 100 different ways to show non-collinear. Really, there's only one way to show collinear, points on the line. Now this leads into. And if you missed it, you could always go back and get it because I'm gonna erase this. Right? So you just try to get the chunks of it. All right? And this will help you with quick note taking, especially when you get to college. And this leads us in kind of that idea of coplanar and non-coplanar. I actually should have just kept that one part that we had up that we were talking about. Lie on same, right? And that's the piece, the one important piece we're taking from the other definition of collinear and points. But what's different about this, like we discussed, is the idea that we're not talking about lines anymore. We're talking about planes, okay? And coplanar would probably mean, or probably be talking about points that are lying on the same plane. Now it could be 2 points that we're talking about, or 3, or any amount of points. All right? And we're going to get to the definition of plane too. I'm actually going to show you coplanar, non-coplanar, and kind of develop our definition of plane here with a cube. So this would be points lying on the same plane. If you want to talk about points not lying on the same plane, okay, let's draw a plane. And let's draw 2 points here, and then maybe 1 point in space. And if you need to look at that visually, picture a table, and I have 2 little bouncy balls on the table, and this one has now bounced. There's a little bounce kind of idea of bouncing here off, and this is not on the table. So this point here would be non-coplanar, the idea that this plane is not lying on the same plane. All right? Now I'd like to bring up this visual of the cube. Let's talk about this cube here. So if you ever want to draw a cube, you draw a rectangle, and then you draw basically a mirror image, same size rectangle right behind it. Same size rectangle. You just kind of lift it up a little bit, and then all you do is connect bottom left with bottom left, top, and you just connect, and then you've made yourself a cube, piece of cake. Now, I want to demonstrate what a plane is kind of with this idea of a cube. We've talked about it with the chair, how a chair needs to have kind of 3 non-collinear points to be standing. If the chair had 3 points in a line, like this chair would fall down. So let's just put a point here. Let's say this is point G. And what I want to show you is that this point G is part of 3 different planes. It's touching the bottom plane, it's touching this right plane here, and it's also touching the front, it's touching the front surface here, right? This point G is touching the bottom, right, and front surface. That's 3 different planes. So I can put 1 point and have 3 different planes. So we're not talking about one unique plane here. Now watch what happens when I add another point. Let's say I add point H. Now I've kind of taken out this front piece, and these 2 points are only part of 2 planes. This bottom plane, right? They're touching this bottom plane here, and they're touching this right plane here. So I put 2 points, and I've eliminated 1 plane. I've got it down to 2 planes, this right side here and this bottom piece. Now the definition of a plane is a unique flat surface made up of 3 non-collinear points. Right? And here's why. I have the 2 collinear points. I add that 3rd non-collinear point, right? There's the 3rd non-collinear point, the point not on that line. And now I've made it where I can only identify 1 plane, meaning these 3 points are only have one plane in common, right? They only have this 1 plane in common. I can only identify F, H, and G with this 1 plane, right? Now I could add other points like A and I could say A is not coplanar to F, G, and H, right? This would be an example of this point not being on this plane. I could add, let's say, maybe point I. A and I are not coplanar. And then you could talk about other things like AI and F. Here's AI and F. Those are 3 points that are actually on the same plane. They're part of this top plane. And they're coplanar. And they're actually collinear, right? So just get you a visual of the cube and what you want to do with the cube when you're working with coplanar and non-coplanar. Basically, if you're working for coplanar, you're trying to find 3 points that all have 1 plane in common. Maybe it be M, N, and O. And if you look at these, M, N, and O, they're all part of the bottom. And that's what you're working with. Something non-coplanar, maybe be N, M, and F. Because M and N are part of the left and the bottom, but F is not part of that, so that's something to be non-coplanar. The next thing we want to kind of talk about real quick, because we're talking about surfaces, we're talking about planes, is this idea of parallel, and skew. And then we want to add, hold off on that, and then we want to add perpendicular to that. So parallel talks about 2 lines that don't intersect, but the key is, 1, they don't intersect, and 2, they're on the same plane. That's important. They're on the same plane. So meaning, if I want something to be parallel, it needs to be on the same surface. Maybe it needs to be on a desk. Maybe I have 2 receivers on a football field running a similar route. Those 2 receivers would be running parallel routes because they're on the same plane and they're running, just had a couple guys in there, and they're running parallel routes. Now something skew, let's compare the 2. Something skew will also doesn't this time, intersect. But the difference here, the difference is this is on the same plane. This is not on the same plane. And the only way to show you that basically is on that cube again, that rectangular solid. Actually, there probably is another way to show that, and I'll do that over here. But I want to use, so here I have this front edge, here's this line, and then here's this line here. Now, this line, obviously we could see does not touch this line. They don't intersect. You see that this line at no point is touching this purple line here. Okay? So they don't intersect, checked. So that could be maybe parallel and skew. Although, if we look here, we see that they're not on the same plane. Well, what does that mean? This front edge is part of the bottom and the front. This back edge we're looking at is part of the side and the back. And because these are not on the same plane and they don't intersect, we say they're skew. So, and you say that kind of like this, skew, right? Don't say it like this, skew. It's not skew, it's skew, right? Work with that. Now there's another one I could just throw in there. Now the symbol for parallel would be if I had lines N and N like this, and I said N is parallel to N. That's a way to write parallel. There is another symbol which you'll see that looks like this. N is perpendicular, and that's one we want to know too.
Is that a B?
Where?
What?
This right here?
Yeah.
No, this is perpendicular. And this is a symbol for this diagram here. Meaning this line, N, it could even go through, meets or intersects at a right angle. It intersects at a right angle here. And that means perpendicular, which is basically the exact opposite of parallel. An example on this cube of something that would be perpendicular would be maybe this line here because they meet at a right angle. It would be like on this football field here, the free safety goes over and meets the receiver directly across, and they meet at a perpendicular. Something skew to the receiver's route would be the field goal post. Yes, they don't intersect. This field goal post does not intersect with the route, although they're on a different plane, so we would say they're skewed because really this field goal post is kind of part of this plane over here, right? They're on a different plane. So you could say the field goal post is skewed to the receiver routes. And that's collinear, non-collinear, coplanar, non-coplanar, and the idea of parallel, skew, and perpendicular.